Hello, a very good day to everyone. Myself Swathi.P from Sri Venkateshwara College of Engineering. So for today's video, the topic is the system software and compiler. Under this, we are going to study the problem solved on this SIC or XC machine architecture. So let us begin. Okay, first we have to see what is system software. System software, it supports both operation and use of the computer and application software. There are two types of software, that is system software and application software. System software basically supports the use and operation of the computer. Application software, it supports and it provides a solution to a problem. Here, assembler translate mnemonic instructions into a machine code that is understandable to the computer. The instruction formats, addressing modes, etc. are of direct concern in assembler design. So compilers must generate machine language in such a way by taking into account the characteristics as the number and types of registers and the machine instructions available. Operating systems are directly concerned with the management of nearly all of the resources of computing system. So under system software and compiler, we have two types of system softwares, that is the SIC architecture and SIC XC machine architecture. SIC stands for the Simplified Instruction Computer, which is the standard model, and SIC or XC stands for Simplified Instructional Computer with extra equipment or extra expensive. This computer is an advanced version of SIC. Both SIC and SIC XC are closely related to each other. That's why they are upward compatible. SIC XC machine architecture is upward compatible. This is the main important part. Okay, in SIC XC architecture, we have few of the features, that is those are the memory registers, data formats, instruction set, input and output. So let us see a little bit brief explanation about them. Memory, maximum memory available on SIC or XC system is 1 megabyte, that is 220 bytes. Standard SIC memory size is very small. This changes in the memory size leads to change in the instruction formats as well as addressing modes. Three consecutive bytes form a word in SIC XC architecture. Okay, so next one is the registers. It contains 9 registers. Like in SIC, we have 5 registers and another 4 registers are extra added. That they are the B, S, T, F. B is the base register whose mnemonic value is 3, and S is the general working register whose value is 4, and T is the general working register. Okay, S and T both are general working register. F is the floating point accumulator, which is not present in SIC but it is present in SIC XC. So the value of F is 6. Okay, so next one is data formats. Integers are represented by the binary numbers. Characters are represented using ASCII codes. Floating points are represented using 48 bits. Okay, so next one is the instruction formats. In SIC or XC architecture, there are 4 types of formats available. The bit is used to distinguish between formats 3 and format 4. Okay, E is 0 means it is the format 3, and E is 1, then it means it is format 4. Let us see about the formats in the further slides. Addressing modes. To use format 3, use of base register and program counter is there. Mode base relative, b is equals to 0 and p is equals to 0. B is equals to 1 and p is equals to 0 for the base relative, that is target address is base plus displacement, that is further we'll see in the while solving the problem. For program counter, the b will be 0 and p is equals to 1, so target address is pc program counter plus displacement. Okay, next one is instruction set. SIC XC provides all of the instructions that are available on the standard version of the computer. In addition, we have instructions to load, store the new registers, that is load, STB, etc. Floating point arithmetic operations, add, subtraction, multiplication, division, register move instructions like R move. This moves the register from register arithmetic operations from register to register. Add, subtraction, multiplication, all these are supervisor call instructions. Okay. So the next feature is input and output. There are input and output channels that can be used to perform input and output while the CPU is executing other instructions. It allows overlap of computing and input output, resulting in more efficient system operation. The instruction SIO, TIO, and HIO are used to start, test, and halt. That SIO is the start input or output, say TIO is the test input or output, HIO is the halt input or output operations of the input channels. Okay, here are the instruction formats that we had discussed earlier. So this is the format one instruction format. Here only the opcode is of 8 bits, and here only 1 byte can be given. Then the next one is the format two, which has 2 bytes. Here the opcode is of 8 bits, and it has two registers, where one register occupies the 4 bits and other register occupies the another 4 bits. Okay, these are the 2 bytes. That is format one produces only 1 byte, and format two gives the 2 bytes. Okay, next one is the format 3. That is, we had seen that the value of E is equals to 0 for format 3, and value is equals to E is equals to 1 for format 4. Okay, here we can see opcode is in 6 bits are occupied, and N, I, X, B, P, E, all these are flag bits which are assigned to the while solving the problem. Okay, 12 is the displacement, or we can say it is at address of the location or the program. In the same way, it is the format 3 is same as format 4, but the displacement or address changes, where format 3 has 12 bits and 12 bits, and format 4 has the 20 bits address. Okay, so now let us see the instruction. Okay, let us discuss this problem. Okay, here we have a problem. Okay, here this is the okay, here the location all has to be given. So let us see how the location is given. And this is the program name. Here this is the opcode, and this is the object. Here the object codes are given. Okay. So first to set any of the location, we have to first see all of these we have to segregate it based on the formats. That is here we can see that the from LDS, LDT, and ADA till here we can say all these falls under the format 3, because the format 4 is recognized by preceding value of plus. So here we can see there is no preceding value of plus. So in this way it is understood that all these fall under the format 3. But here yes, X and XT, there are two registers where S is also a register and X is also a register. And for comprehension for X is also registered and T is also registered. These two fall under the format 2, which only gives the 2 bytes. And ADLP, this falls under the format 3. So let us assign the location. So 4000 is the starting address. So 4000 is given the same. Uh, okay, so 3 bits are added to 4000. When 3 bits are added to 4000, it becomes 4003. When 4003 is again added to 3 bits, then it becomes 6. And the same way till F, it's the same. And 12 is okay, till F, okay, till 12 or 3 bits are added for each location. Okay, here it has become 2 bits because the S and X falls under format 2. So 12, 4012 plus 2, it gives the 4014. Okay, next is the same way 4016, that is the 2 bits are added. So 4019, 3 bits are added because ADLP is the format 3 register. So 4145, here how this we have got it. Okay, here these three falls under the 100. It is a words are 100. So as we had seen that one word is currently equal to 3 bytes. So 100 into 3, it normally gives us the 300. So 300 is basically in 300 is basically a decimal number. So to convert it into hexadecimal, we have it is 300 hexadecimal is 12C. So when so to 12C is added to the previous register, previous location, that is 4019. So we get 4145. In the same way, 427 and 43, 90 is taken. So okay, these are all the opcodes of the given object codes. Okay, first start, it is the same value. Okay, let us see LDS. LDS, the object code is 6C. Okay, as it is a format 3 of it, the opcode 6 bits are occupied. So 6 in decimal value is 0110, and C is 11, and other 2 bits are ignored because we need only 6 bits. Okay, here the hash value is nothing but it's the immediate register. So I is given 1, n is 0, and x is 0. All b, p, e all are 0 because there is no base relative program counter, and e is 0 because it is the format 3. So displacement or address is given because here it is a 3. So we let us write it in Excel 000. We have to write it in 12 bits. Okay, after writing, we have to segregate them based on the 4 bits. Okay, 0110 is 6, and 1101 is D. Okay, 4 zeros are a 0, then a 0, 3. Okay, this is the object code for the first instruction. In the same way, we have to see for LDT. LDT is 7 4. Okay, 7 is 011, and 01 is for 4. Okay, here also we have a immediate addressing mode. Okay, in immediate addressing mode, we make I is equals to 0 and E is equals to 0 because it is format 3. 300 cannot be written as here 3011 0010 like that, because 3 is in decimal value, so we have to convert it into hexadecimal. So 300 hexadecimal value is 12C. So 12C is written here. Okay, 12C. Okay, one, this is 1, and this is 2, and this is C. Now, while grouping 4 bits, we get the object code here 7, and 0101 is 5, and the 4 zeros form 0 and 1 2 C. This is the second address of that. Okay, next one is the hash. Hash again is the immediate value. Here we have to see the LDX value is 04. 04 is represented in 6 bits, and N is 0, and I is immediate. So it is immediate, so I is given 1. X is 0, B is 0, P is 0, and E is also as well 0. So, so the 0 is already given. So while grouping it into 4 bits, we get this object code. So let us see the next condition, that is alpha X, and there is another register. So whenever X is there, that is the index register, we make it 1. And alpha, it is a format 3 address. So N and I is given 0 because it is with 2 registers. So it can either be direct or it can be immediate. So it is made to 1. So let us see the location of alpha here. It is 4019. 4019. It is in 16 bits, but we need it in 12 bits. So let us find the displacement value. The displacement formula is operand address minus program counter value. So 4019 is the operand address, and 40CC is the address of the next next location of the opcode. So we get 00D that has been represented in the 12 bits. So while grouping all this, we get 0, uh, 3, and 010 is here. This is the object code for the problem. Next one is the beta x. Beta x, here we can see that beta is 4145. So again here we can't represent the 16 bits in the displacement because format 3 has only 12 bits. So we have to find the displacement value. So we get 136 that is represented here. And the next one is the gamma. Gamma is also the same. It has 4271. While finding the, we have to 5F. Okay, in this way, all the displacement values are calculated. So the next two, that is SX and XT, both are of format 2. Format 2, the object code is 8 bits, and registers are R1 and R2. Here R1 is 4 bits and R2 is also 4 bits. So here add the value of S is actually 8 bits. It's represented in 8 bits. Had R is nothing but 90 is represented in the 8 bits, and S is 3 value, and X is 1. Okay, so the value of X register mnemonic value is 3. This, okay, its value is 3, and register X is 1. So in this way it is represented, and while grouping them in 4 4, we get 9041 as the object code. And X and T, this is also okay. COMPR, the value is EAO. So we get the following in the 8 bits, and the value of X is 1 and T is 6. So 6 is represented in the same way, and we get the following in the same way. We calculate, okay, JLT is a format 3 register. So in the same way, JLT is 38. We represent 38 in the 6 bits, and N and I is here. X is 0 because we don't have an immediate addressing mode. So X is okay. We don't have an indexed addressing mode, addressing register. So it is 0. N and I, it can be either direct or immediate. So it is 1. So here B is 1 because it is a program. Because it is base relative. So it falls under the threshold value of 204 minus 2048 to 2048. So we write it in this form. And this way we calculate the object codes of the given problem. Here to write the object format, this is the header, this is the header, this is the text, and this is the head. Here example is written from 2 to 7 bits, that is EX, AMP, E is ignored because we have to write within 2 bits. So the next is the starting address of the location, that is the 400 that is 6 bytes, and the next one is the end of the length of the address. So we have to minus 4000 minus 439, you get the value of 0039. The text address is written within the 59 bits, 69 bits. Okay, the last. Then the end address is nothing but we reach the end. So in today's video, we have seen the SIC machine architecture, the working, few of its features, and so and so. The main point we have to keep in mind that finding the displacement, that is the operand address minus PC value. PC value is nothing but program counter value. Operand address is the operand address which is given. Like for example, alpha's operand address is 4019, and PC value is nothing but we are finding LDA's object code. So the LDA's next location of the LDA is 400C. So operand code minus next address of the object code is equals to 00D. So in this way we can find the object codes of the given problems. So thank you guys thank you so much. Have a good day.